Hello, hello, hello. It's my third video in a row today. I've just been knocking them out. I haven't even gotten out of my seat yet. Uh, yeah, gonna end up with 3 videos, I think. So it's kind of funny on the KiloTube video pace, and it's not because I'm trying to make a bunch of videos. It's because I'm trying to quickly go through all the things that I want to do, and turns out that recording videos is good. Sort of general pressure on myself to actually just do it and not mess around. So interesting. Okay, well, um, so now we're looking at the miniKanren hacking episode 3, Wednesday, January 8th, 2025. Just notice that the one I had yesterday said Tuesday, January 7th. That was logical. Sorry, that was actual Tuesday, and this is actual Wednesday. It's what, 1:50 a.m. on Wednesday morning, but of course logically it's Tuesday because I haven't gone to sleep yet. So this is, just keep that in mind if you are keeping track at home. I don't think anyone cares about that other than me, but yeah, so it's still logically Tuesday in my mind. All right, so yesterday we played around a little bit with using the absento, and observed that quines and twines seem to differ structurally only at the outermost level when, using this absento trick. So, one question is there a way to make them differ more? I don't know. Well, let's play around with it a little bit more. I don't have a lot of energy in me right now. I'm gonna go to bed pretty soon, I think, but we can mess around for a little bit. That was not the right key to hit. I think that's showing I'm a little tired. That's okay. All right. Okay, if I can't remember how to start scheming Emacs, that means I'm pretty tired. But okay, we'll get through this. There we go. There we go. Although I'm starting in the wrong directory. Okay, that's more like it. Okay. Okay, that's what we looked at yesterday. So that's the first non-trivial. I mean, that's the first twine pair that we get. I shouldn't say trivial or not, but we're using the absento technique, right? So we had originally we used disequality constraints, just a single disequality constraint. Whoops. To say that x and y are distinct, and we observe that structurally these two expressions are the same. It's just that there's a quote on the first one. Whereas here, we get a little more variation. So here we have a call to list on the outside versus an immediate call to lambda. So the immediate call to lambda in scheme is equivalent to a let. So it's like we have a let versus a call to list. Okay. But if you look inside, you know, this lambda nil thing. Well, it looks like that. This triple quote lambda thing, that's the equivalent to the double quote. So we just added a quote here, added a quote here, and you know, have a list here. So they're not so different. A little bit different. Let's see if we can generate some additional twines. Okay, so here's another one. Okay, we have another list, another direct lambda. Now I will say our interpreter's pretty small. Like our language is pretty small, so it's not like there are that many ways to construct list expressions with what we have. You know, so that's one thing we could do. Let's go in here. Okay, so there's no Q2. Let's see, this file is q2.scm. All right, so here, if we look at the interpreter, the eval expo, so I'm calling evalo, which is like a wrapper, and it just passes in an empty environment to eval expo. And here we're using an explicit, you know, we're passing in not an initial environment, but an empty environment. So a more sophisticated interpreter might have bindings for like list. List would be bound in the initial environment. It'd be a primitive, and just do a variable lookup. Here, it's more like a special form. You know, we have a special case to match against list expressions. So yeah. But okay, so we have quote, we have list, we have a variable lookup, variable reference, procedure application, you know, unary argument, you know, single argument application, and we have lambda expression where you have a single argument to lambda expression and single body expression. So one thing we could do if we want to have a little more variation is maybe we add something besides list. How about we add cons? Okay, so we'll say cons E1, E2. You know, we could also do like car and cutter type things. Cons E1, E2. Cons should not be in the environment. Might play around with the split environment representation that Darius Bacon advocates. So, not-invo, absento, closure. Okay, so here's a side condition to make sure we don't accidentally introduce closures. The E1's not a closure. You know, we're trying to make sure that we don't end up quoting closures. Now, I think this absento really could be brought out, probably. I don't think this is necessarily optimal. Yeah. In fact, I think the quote does it. Is it really necessary to even have this on list? Because somehow you need the closure tag, and yeah, okay. Well, it's safe to do it this way, so we'll just leave it like that. I think you can get into trouble, actually. All right. Closure's not in there. All right, here's the here's what we need to do. We need to make 2 recursive calls. So E1, evaluate E1 in the current environment and E2 in the current environment. We also need to say what val is. So val is going to be v1 dot v2. Okay, so E1 evaluates to v1, E2 evaluates to v2. Okay, I mean this can be cleaned up some, but that's sort of besides the point for right now. And we gotta get rid of these commas. Okay. I don't really like exp, by the way. I'm gonna change all those exps to expers. And the reason I'm doing this is because in scheme, exp is built in. That is the exponential function. And you can run into a problem where you end up with a free variable exp. Saying, yeah, right now here, this expr is bound. That exp was bound, but if you're not careful and you end up with the sort of free occurrence of exp, that'll end up being bound to the global definition, which is the exponential function. And you think you have some expression, some argument representing an expression for your interpreter. It's actually just a scheme function bound to exponential function. That sort of thing can be really hard to debug. That's when you might want to do some software engineering things with namespaces and all that, but we're not going to mess with that. Okay. All right. I'll grab the expression, but I'm going to close Emacs. Or sorry, not close Emacs, but close that. That Shay. And I just don't want to accidentally load Q1, or sorry, Q.scm. That's also another classic mistake. All right, let's see if anything's different. It's taking longer. That's not surprising. Okay, let's see what we got. All right, didn't seem to change a lot. Let's just look at the Quine. Let's just look at a Quine example. Okay, the standard Quine. See if we can get anything that uses cons. Okay, the second one uses cons. Let's make sure that's really a Quine. Yep, looks like. Okay. Let's go back to the twines. Okay, what do we got? All right, here we have conses in both. You got a mixture of conses and lists. Huh. Now we could add quasi-quote. That there are clients that are using quasi-quote, which you can see is the last example in the 2017 ICFP Perl, for example. Okay, well, I guess the thing is, yeah, we've added a little variety here by having both list and cons. However, we still have the same exact structure. You have some quoted lambda expression, triply quoted version of the same exact lambda expression, looks like, yeah. And then you have basically a similar sort of thing here, except here we have the lambda at the top level, unquoted, being applied directly, and then another copy of it, with 2 quotes instead of 3. So, if we wanted to look at this structurally, yeah, let's look at this structurally, I guess. So all right, we have P and Q. So that's P, this is Q. Don't really need to put them in lists, I guess. Okay, so that's what P and Q look like. Let me actually just copy those over to Q2. Hashbang EOF, that's into file and Shea scheme. Everything after that's ignored. Okay, so let's play a little game here where I just want to name the parts of these and then sort of substitute out. So I want see if I can do this correctly where these are just Emacs editing commands. Okay. So I'm going to do some search and replace. Yep, they're all identical. Okay. Where expr is this thing. Okay. So now we can see the structure of those twines P and Q. So we have a list, we have singly quoted expr, triply quoted expr, and then here we have an application of expr to doubly quoted expr. Okay, so structurally, that's what it looks like. And expr itself happens to be this thing that has this a lambda expression, takes a single argument, has a call to list, and then quote of list, then whatever this thing is doesn't matter. The name of that variable is, and then a cons of quote, quote, to cons of call to list, to quote, quote, to that formal parameter again, and quote empty list. Okay. So I guess the question comes down to, is there some way well, first of all, are there quines that exist that look anything of this form where, or twines that exist where, you just don't have expr copied over and over again and shove some quotes in front of it. So here we have a list call. Here we have expr is, a lambda expression just being directly applied. So that's the structural variation other than putting quotes on expr. Expr appears twice in both of these lists. Notice like how many quotes we have. So we have expr appearing with 0 quotes once, 1 quote appearing once, 2 quotes appearing once, and 3 quotes appearing once. So every time expr appears, it has a unique number of quotes on it. So I guess the question is, are there other structures that that we might have, or what about could there be an expr 1 and an expr 2 that are different? What does that look like? So just trying to figure out if they're sort of more interesting structures. I think this sort of quine is always just going to have some sort of quoted expressions and being pushed around. Then there'll be one version that's not quoted. It'll look something like this, but maybe there's something that's sort of more interesting structurally to explore. Okay, well, I think that's it for tonight. If you have any ideas about this or cool examples, let me know. Thanks. Have a good one. Hope to talk to you soon. Good night.